First we have to define what does pure inductor mean. Pure inductor is a coil. It's a coil with self-induction because every coil has self-induction according to the equation mu n squared A divided by L. Of course this coil will have self-induction now. However, with negligible resistance, yani R is going to be 0. In reality, it's not possible because there are wires. Every wire has a resistance. That's why resistance cannot be 0. But first we are going to study ideal. Assume that this is superconductor, so its resistance is 0. So then this coil is going to be a pure inductor. Pure inductor. It is only L but no R. So we are not going to think about R when we are studying this title now. A pure inductor is a coil with self-induction L but with negligible resistance R is equal to 0. As you see, we connected a coil to a generator with a potential difference equation Vm sine omega t. And we connected a voltmeter across the coil to measure the potential difference. And we connected an ammeter for calculating and measuring the electric current through the coil. But here is something. Maybe you remember self-induction title in 6.1. When we give electric current to the coil, electric current is initially 0. Remember, the magnetic field through the coil was 0. Magnetic flux was 0. But later we switch it on. As soon as we switch it on, what happened? Electric current increased to maximum. Magnetic field increased to maximum. Magnetic field inserted to maximum. So there is a change in magnetic flux. And there will be a self-induced magnetic field. Of course, self-induced current as well. But that self-induced current was in the opposite direction of the main current. Do you remember this? In 6.1? Now, in here we are going to use this because alternating current is continuously changing. Just like switching on, off, on, off, on, off. Here is always changing through the coil. Yeah, because of the self-induced current in the coil, because this current is in the opposite direction of the applied current, current cannot be maximum very quickly. Because self-induced current always opposes the main current. Maybe you remember it. But potential difference becomes maximum as soon as you start the circuit. As soon as you start the circuit, potential difference gets maximum value. However, because of this opposite directed self-induced current, electric current cannot get maximum value. There's a time delay for electric current. What does delay mean? You know? Yeah. Late. A little late. When the potential difference is maximum, electric current is 0 because of self-induced current. So because of the self-induced current in the coil, there is a time delay for current supplied to the coil compared to potential difference. Okay, what does it do? When potential difference is maximum, electric current becomes 0. Then electric current increases, becomes maximum, but potential difference becomes 0. Yeah, electric and potential difference are not changing together. Oppositely changing. That's why reading of the voltmeter and ammeter are different. When reading of the voltmeter increases, reading of the ammeter decreases. When reading of the voltmeter decreases, ammeter increases. When voltmeter is 0, ammeter is maximum. When voltmeter is maximum, ammeter is 0. Why? Because of the self-induction of the coil. Now, can you say that they are in phase now? No, they are not increasing together. They are not 0 together. They are not maximum together. So they are not in phase. They are not in phase. Huh? If they are not in phase, which is called being out of phase. Yani you are going to be in phase or out of phase. So then, increase, decrease, decrease, increase, 0 maximum, maximum 0. This fact is defined as being out of phase. Electric current and the potential difference are out of phase in a coil, in an inductor. But they are in phase in which device? So electric and potential difference are in phase in pure resistor, but out of phase in pure inductor because of self-induction.
So they are different in phase?
Yes, they are different in phase.
Yes.
because of self-induction. Electric current potential difference are out of phase in a pure coil or pure inductor. Okay, out of phase, but what is the angle? How much out of phase? We can see it. Look at it here. Here is the potential difference is 0, but electric current is not 0. Where is the electric current 0? Okay. Here is the electric current is 0. Here is potential difference 0. What is angle between these 2 points?
Okay.
Half cycle is 180. Half of half? 90. Yani this angle is 90. Angle between these 2 points is 90. Yani electric current ile potential difference are out of phase by an angle of 90 degrees. So what is angle between this 0 and 0 of the electric current? Again 90. Here is the potential difference is 0, but after pi over 2, electric current is 0. It takes pi over 2 angle to electric current to be 0. This tells you that electric current potential difference are out of phase by an angle. How much? Pi over 2. So that's why we'll say that in a pure inductor, electric current and potential difference are out of phase by an angle of pi over 2. What about the resistor? What is the resistor? They are in phase. Phase angle difference is 0. But in pure inductor, it's 90.
Teacher, can we say like the current is delayed by pi over 2?
Delayed, yes. Delayed by pi over 2. But instead of saying that, we will say opposite. If current is delayed, potential difference is forward, in front. So potential difference across the inductor VL leads the current by a phase angle of pi over 2. We define potential difference generally according to electric current. So potential difference is leading electric current by what angle? Pi over 2. If it is leading, equations cannot be same. Equations must be different. This is electric current equation. I am sine omega t. So potential difference equation must be leading by pi over 2. That's why we added in here pi over 2. And they are not same. Remember in resistor, they were same. Their phases are equal. Omega t, but now not equal. Phase of electric current is omega t, but phase of the potential difference, omega t plus pi over 2. This is saying you that, positive pi over 2 is saying you that potential difference is leading electric current. And also from this graph you can understand that. So as you see, this angle is between the red line and the blue line is 9, again 90 pi over 2. We can also represent this by phasor, vectors. Leading by pi over 2 is also represented by two vectors perpendicular to one another. Electric current phase, omega t, we take it in horizontal. But potential difference is omega t plus. Plus is clockwise or counterclockwise rotation in mathematics? You should rotate V by angle of 90 degrees. That's why V is going to be invertible. This angle is how much? 90. This is the phasor which represents that potential difference is leading electric current by an angle of pi over 2. Okay. And of course, self-induction circuit and inductance circuit or self-inductive circuit and the resistors are different. Like what? In resistance, collision of the particles with the electrons, collision of the electrons with other particles making the resistance. Remember? We define resistance this way. While electric current is flowing through a conductor, so these electrons which are in motion, which are called mobile electrons, collide with other immobile electrons, and this opposition is named as resistance. But in here, opposition is not because of the collision of the electrons with other electrons, because resistance is 0. But there's still an opposition to electric current. Still, there is an opposition to electric current. This opposition is coming from self-induction. Remember that? In a coil, if you make a change in electric current, coil reacts this change. Chapter 6, section 1, which is called self-induction. Induction, remember. Yani
Because
here
of
is
self-induction,
yes,
less
exactly.
flow, the negative.
exactly.
Okay.
So because of the coil reacts to change in electric current, because AC is what does AC mean? Continuously changing electric current. Because electric current through the coil continuously changes, coil reacts this change and produces an opposition to electric current. This opposition is named as a different name than the resistance. Inductive impedance. And represented by XL. Yani inductive impedance XL is the opposition of a coil. Opposition of an inductor to the flow of an alternating current called inductive impedance. Inductive impedance can be calculated only if the current is alternating current. Yani it must change by time. So how can we calculate this opposition? Usual method. Use Ohm's law. What is Ohm's law tells you? VE over IE or VM over IM. Both of them defines opposition of the coil to the electric current, which is called inductive impedance. Yani XL can be calculated by VE over IE or VM over IM. What is unit of XL? What is unit of potential difference? Volt. What is unit of electric current? A volt per ampere. Same as the resistance. Their units are same. XL has the same unit as resistance. Dedim ya, the natures are different. In resistance, electric current particles collide with other immobile particles. It's collision between them. It's causing resistance. But in pure coil, it's not about the collision. It's about self-induction. What was the self-induction? So coil reacts, changing current. This reaction to the changing current produces this inductive impedance. Yes. For that reason, we say that inductive impedance can only be calculated for changing current, yani AC. For DC, we cannot calculate it because direct current, coil does not react at direct current if you don't make a change. So inductive impedance depends on, for that reason, two factors. One of them is absolutely L, because L inductance, coefficient of self-induction. It's only for the coil. Absolutely, in your equation there must be L. Second one is there must be a changing current. A changing current is called what? AC current. AC current has what? Frequency. F. How quickly is the change? Inductive impedance opposition is that big, directly proportional. How slowly is the change? Less the position with small inductive impedance. No change? Zero inductive impedance. Yani F. F must be in your equation. So one of them is L, second one is frequency of the generator, F. And when we insert these two into this equation, this is the equation for calculating inductive impedance. 2 pi F L. What is 2 pi F? Omega, yes, you are right. Omega L or 2 pi F L is the equation for calculating inductive impedance of a coil, pure coil.
Teacher, we are using visual for
Both of them. For Ohm's law, yeah, this is what by Ohm's law we can calculate X. This is the general opposition. Not only for XL you calculate it, for R you can also calculate this. But this is only for XL. Yeah, it's only. Where does this XL come from? What is origin of this XL? This is explaining that. Now let's solve a problem. Calculate self-impedance. Self-impedance, inductive impedance, same thing. Calculate self-impedance or inductive impedance, XL, of a coil of self-induction 0.04 Henry. 0.04 Henry. L. This is L. Connected across a source of frequency, F. 100 Hz. Yeah, L is given 0.04 Henry. F is given as 100 Hz. Calculate inductive impedance XL. Yes, XL is omega times L. But omega is not given, so we should calculate omega as well. 2 pi F. Write them all and calculate. 2 pi 6.28, we know it. F is given as 100 in the question. L is given as 0.04. Multiply them all. 25.1, I think, huh? 25.1 ohm is the answer. Question number 2. An AC source for instantaneous value. This is the generator equation. Source is generator. V is equal to 10 sine 50 pi t. So, what is the generator equation? Let's remember. V is equal to Vm sine omega t. Instead of Vm, what is written?
10.
Yes, maximum potential difference is 10. Instead of omega, what is written? 50 pi is omega. So from this equation, we get that. Vm is 10 volts. Omega is 50 pi radian per second. And this generator feeds a coil of self-induction, 0.1 Henry. This is L, 0.1 Henry. L is 0.1. Find the maximum value of the current. I maximum is the question. Through the coil. Find maximum value. I can use Ohm's law.
Yes.
Ohm's law Im tells you that Vm, we know what Vm is.
Yes.
Only I need to know what is XL. Because
Yes, they are.
no R
same.
in here of the
Yes.
coil, that's why we are not going to write R. We have opposition of the coil, which is XL. Vm over XL. Vm is given, but XL must be calculated. We have to calculate XL. So we know equation for XL, which is omega times L.
Yes.
L is given, omega is given, yes, both are given. Omega is 50 pi, L is 0.1, multiply them. 50 pi, pi is 3.14, L is 0.1. When we multiply them all, result is going to be 50 pi, multiply them all, result is going to be 15.7, I think, huh?
Yes.
15.7 ohm. Now we got XL, it's easy to calculate now. I maximum, because Vm is given in the generator equation as 10 volts. XL we calculated at 15.7. So result is going to be 0.63 ampere. This is the maximum current. What is the phase angle difference between potential difference and the current in the pure coil?
The coil 19.
90. There are no need to calculate it. Pure coil, potential difference between the electric current and the phase angle difference between potential difference and electric current is 90, yani pi over. A coil of pure self. L is given, so we don't need to know what does it mean. L, coefficient of self-induction. L is 0.02 Henry. A negligible resistance, which means it's a pure coil, is connected across an AC source of frequency 50 Hz. Frequency of the generator is 50 Hz. Find the self-impedance. Again, XL is the question. Self-inductive and inductive impedance. XL. Find XL of the coil. And the effective current through it. Calculate XL and effective current, i.e. if the effective potential difference is 125.6 volt. Effective potential difference is 125.6 volt. Write down the expressions of instantaneous current and instantaneous potential difference across the coil in terms of time. Yeah, and these are the equations, remember?
Yes.
Write down expression means insert constants into these equations. Which quantities are constant? Omegas are constant.
Yes.
First calculate omegas.
The instantaneous current means this?
Yes, right. Insert the constants, leave variables. Don't write for variables. T is variable, V is variable, T is variable, I is variable.
Yes.
But omegas are constant, you should calculate omega.
Yes.
V maximum is constant, you should calculate V maximum also. First calculate omega, second calculate Vm, third calculate In, then insert them into these equations, so you will finish writing expressions. But first let's calculate XL. XL is a question, and also omega is a question. So omega 2 pi f, we know it. Omega is 2 pi f. Because in this equation generally we write omega in terms of pi.
We will not.
Yes, don't write pi first for this one, but for calculating XL we need it. So 2 pi f, 2 pi f is 50,
100.
which is going to be 100 pi radian per second, or instead of pi, if we write 3.14,
340.
yes, it becomes 10 times 3.14. Also, we need this one, both of them we need. 314 radian per second. This is I. This is omega, sorry. 100 pi or 314 radian per second. XL. XL, let's calculate XL. XL is equal to omega times L, we know it. Omega times L.
Or omega is 100.
Omega is 314,
Yes, 340.
yes.
And L is 0.2.
L is given as 0.2. 314 times 0.2. Answer is,
0.62.
it is not 0.6.
It's 62.8.
62.8 is correct. Almost 63.
63.
63 ohm is the XL. After XL, we can calculate effective current by using Ohm's law. Because we know what the effective is.
Yes, we can find
IE can be calculated very easily. So, IE is equal to VE divided by XL. Ohm's law. VE is 125.6. 125.6. XL is 63. Result is almost 1.98 or something like that. 1.98? 1.98 ampere is the effective current. We calculate effective current. Now, these two are asked, we answered them. But to write the expression, we need to know what is IM, what is VM.
We can find IM.
Let's find them one by one. Second, calculate VM. Effective current, effective potential difference is given. Multiply effective potential difference by root of 2. Find it. So, VM is equal to effective potential difference multiplied by root of 2. And 125.6 times root of 2.
178.
178 volts. So we got what VM is. Also, IM is needed.
Also, we can find.
So, IM is needed. It's not needed because IE is already calculated IE. Multiply by root of 2.
Yes.
This is the easiest way. It's okay that way, you can go that way as well. So, IM is IE multiplied by root of 2. IE is, we just got it, 1.98 multiplied by root of 2. 2.23.
83. 83.
83 ampere. Now we found them all. After that, insert them into these equations and finish writing expressions. So let's do the potential difference first. VL, instantaneous potential difference across the coil, is equal to, what is VM? How much is VM? 178 volts. 178 volt times sine omega t plus pi over 2. Omega is, generally we are going to write by pi, 100 pi, but I shouldn't forget pi over 2 plus pi over 2, put them into brackets. This is expression for instantaneous potential difference. Only we wrote V, omega and Vm in here. But for instantaneous electric current, IL equals to coil, what is maximum current? 2.83 sine, what is omega? 100 pi. 100 pi, don't forget T. This is the expression for instantaneous electric current. This is the expression for instantaneous potential difference.